All right. Hi, everyone. Wesley here, and welcome back to the third video of my solid series with C Sharp. Today, we're going to explore the Liskov Substitution Principle, also known as L, LSP. The L in solid. It's one of the most subtle but powerful principles when it comes to writing robust object-oriented systems. So, what is LSP? The principle was introduced by Barbara Liskov, and it says objects of a superclass should be replaceable with objects of its subclass without altering the correctness of the program. In simple terms, if you're using inheritance, your subclass should behave in a way that doesn't break the expectation or the parent class. So I will show this case. So we have here our LSP sample, and we are executing without SLP. So we have customer, and we have the SMS only customer. And we have this notification service. And if we came here in notification service, known as LSP, we have this function called notify that receives a customer. And if this customer have an email, we will send the email. If not, so here I put just something else. It could be only this, but I put something else because I want this message. I want this. Maybe if it don't has an email, nothing happens, or it could be an exception because I'm expecting that it has an email. Maybe the SMS only customer doesn't have this email, and it could have an exception here. So this is just an example. If I run this right now, let me run. Where is my window? All right. If I run the SLP, LSP 2, so Liskov Substitution Principle, no LSP sample. So first, what we are doing here, let's go back here. So we are creating a list of customer, and the first customer has an email, and the second customer don't. So what is happening here? The first customer is sending an email, and the second one don't. So maybe nothing happens, or it could be an exception. And we have here, so sending the first customer is sending an email to Wesley email.com, or nothing happens, or it could be an exception. So let's refactor this. Uh, let's change this. I will close this. I'm not using this. Okay, we can use this maybe. Phone string phone. All right, everything it's okay here. So now, what is wrong? Actually, this works for regular customer, but if we try to pass SMS customer, so we can get maybe an exception. In this case, I just change for nothing happens. So what went wrong? The problem, here's the problem. The subclass can actually substitute the parent class safely. It violates the contract. If we expect every customer to have a valid email, then subclass shouldn't break that assumption. So let's refactor this. First of all, let me just get back here. We have this. Let me close this. So we have the LSP file here, and let's add interface, the interface, and let's build this notification service. So I have a notifiable. I notifiable. It's a public interface, and you can change this. And all right, we have a void notifier. That's it. Pretty simple. And then we can create another customer. So first we have this customer here, SMS only customer, and we can add email customer. Email customer. It's a public one. And now this is for I notifiable implementation interface. And now I have here the email. So privacy, oops, privacy. All right, guys. I don't know what happens with my previous video, so let's just continue here. I just clean everything, and let's just continue the video. So first of all, I create the iNotifiable interface here that just notify. And now let's go on and create our new classes. So model, let's create another one, the email customer, for example. Mail customer. All right. Stands for I, notifiable. It's public. And we're going to change this. Convert and implement interface. That's it. And then we need a private string, private read-only string email, and a constructor. And this constructor will have a string email, which email receives email. That's it. Pretty simple. And let's create another one. For example, SMS customer. SMS customer, which is almost the same. So public and is an I notifiable. Let's implement this. Let's change this just because I like it. And all right, we have a private read-only phone and a constructor who receives a string phone, and we have phone and a console message just sending SMS to phone. And I forgot here. So console send email to email. And that's it. This is our to class. Let's go here to SMS sample, and I will copy almost everything here because it is almost the same. And all right, we have a list of I notifiable, and we have a new email customer, like this, and an SMS customer like this. And we have a new notification service, SLP, almost like this. And let's create this service. notification service. So what it does, only, so let's change for public interface. That's it, and it just send. So public void send. And the send is you. Oh, all right. We have to use an I notifiable customer, and this customer only notify. That's it. So let's get back here. We have a notification customer, and for each notification service, we have a notify customer, notify. No, it's recording again. Oh, right, all right. So each customer is notified through their preferred method, and the code is now 100% compliant with LSP. So the main lesson here is when using inheritance or implementing contracts, your subclass should behave in a way that doesn't surprise or break the expectation of the caller. Throwing exceptions for methods that should work is a red flag. It's clear violation of LSP. So by applying the Liskov Substitution Principle, you make your code safer, more predictable, and easier to extend. So in the next video, we'll move on to the I, interface segregation principle, where we'll learn how small focus interface can prevent a lot of pain. A lot of pain. So thanks for watching, and sorry for interrupt my previous video. And thanks for watching. Let me know in the comments if you ever broke the LSP without realizing it. And that's it. See you guys next time.